Uh, Welcome, everyone. I'm Joey Lee from Taipei. As usual, because the travel budget is expensive, the cost is expensive to us to fly to here. So every time I try to deliver some talk, maybe not very high end or many hacking, but and sometimes it's easy. But yeah, let's show it. This time I want to introduce some new things. In the SUSE Shim. Before last year, I also delivered a talk about the SUSE Shim, but this time I just want to introduce some new things. So the agenda is I still describe some background of the SUSE Shim, and then some new things like the NoSQL, for alignment, and the certificate wrapper, and the SBAT label, variable test file, and the options, and the UKI, and the Signing EKU support, and the HSI status. Maybe some feature is not. I'm not sure is maybe not really useful, or maybe useful, or maybe it can give you some idea in some use case. Okay, about the background, as we know, maybe I'm not sure, maybe some just in case some guy don't know, the Shim is the first bootloader in the UEFI environment for supporting the Linux to put to the grub2. The point, the original reason for the Shim project be founded is because the license, because the grub2, the license of grub2 is a GPL, and we all know nobody want to sign a GPL2 or more the bootloader, so that's why we now the Shim project happened, and it has a better, not it's not better, but not like the license is a BS2. And our association is based on the upstream version, of course, and we put some downstream page, and we are trying to remove those downstream page or contribute those page to upstream, but some pages about our use case or our slave environment. So we are still doing that. And special things is Shim is a special package in the slave world, all slave version, including very old slave, share the same binary, Shim binary, and even like the tumbleweed also use the same code, just has a different built-in certificate. So last day we use the slave CA, and on the tumbleweed we use the openSUSE CA. And of course, those binaries, the same, but just assigned by different key. And it must be reviewed by Shim review project on upstream, and will be signed by Microsoft key before release. I will introduce the process later, and the version, the timing of the version upgrade is not always upgrade to up to date, because there's some risk. So we will we will co-work with the security team to find out the timing for when we want to upgrade the Shim. Normally when the grub2 or Shim have a problem like a boot hole security problem, then we put many page for fixing those boot hole. Then we will consider to release a new Shim. Current status is now we delivered the Shim 15.8 version, and prepare in the 16.0. So this is one very simple picture to show how does the chain of the trust of the UEFI and the Shim. So very simple, the UEFI firmware will verify the Shim by the DB or DBX, and Shim will verify grub2, and the grub2 will verify kernel. It's a very simplified picture. And this picture is a more detailed. It's a more detailed, like the if grab 2 load the kernel to the memory, then grab 2 will call the Shim protocol. The name is a Shim underline lock to verify the kernel in the memory, and Shim will use the DB or DBS or MOK. The name is MOK list is a real name, variable name in the NVRAM, and also will verify SBAT. The SBAT is another mechanism because the NVRAM, the space of NVRAM is a limit. So now it's almost full now. We cannot put more DBS. So SBAT is a user string to and the timestamp to fill out those old grab2 or even Shim. Kernel is also can support SBAT, but the page is still reviewing on option. Not my contribution, but I looking at it. Yeah, it's a one simple process. Okay, then is our internal, not really internal, is also related to open source for OpenSUSE for our Shim for delivery. In the development stage, we start from the factory, of course, and they have one Shim package, but it's not real Shim for delivery. Then because we need to send one stable binary for the Shim review project, so it's impossible to use a factory because the tool chain sometimes change. So we copy the Shim to the source code for it. Just copy to one sub-project. The name is secure boot. Then currently is the code base is a lib 15.5, and it can build out one stable Shim binary. Then then our security team will send to the Shim review project for review. Now after that, a secret process will be sent. Our Shim binary will be sent by our security team to some guys I don't know who to sign by Microsoft the key. Some on option, some guys say some people hold the Microsoft key is in our community, but I don't know who. Yeah, and the issue, as I know, we need to trigger file one request on the Microsoft website. I'm not sure the detail. Yeah, so, and the same process is also for the state. Just the code base code is the same. Just push to the one stable release. Currently, we use the state 15 SP3 update, yeah, as the stable release. We can use other project, other step, but currently we still use it because we discussed with the security team. Then after that, the binary be produced and also sent to the Shim review for review and sign. After the sign stage is finished, review and sign stage finished, then the binary will back. Then we will extract the signature and update to our Shim package. Then after the RPM be built out, then we will copy to the Shim lib. So the Shim lib RPM is a real RPM for deliver the Shim binary to our end user. And the same process is also in the state. And like here, currently we use 15 SP3, so other like 15 SP4, SP5, 56 and more are inherit from this copy. So and then we deliver to the state and the lib, and the yellow paste is for the tumbleweed. We will deliver to tumbleweed and also tumbleweed up version. Okay, then it's a simple background. Then I will start to introduce some new things. It's not really a new thing because like this topic is about NX and 4K alignment. NX means no execute. We all know the code, the code be put in the one memory region. It can be set to executable, but should not be writable. Yeah, so it's a the Microsoft has one time to launch one spec or requirement say that we should anything including the Shim bootloader and other EFI applications should be supported is the functions and must be before they signed by the Microsoft key. And so the so now NoSQL is also need. It means that your P file binary file must align with a 4K page size because we don't want to outside the boundary, so it must align for the 4K area. And at the same time, the session flag cannot combine the write and the execute. As I said, it cannot be execute, cannot be executable region, but also can be write. It's dangerous. Then after that, our PE binary should set the one flag. The name is NX compact flag to our header, PE header. Then maybe our last load stage is load like firmware in firmware image loader can check this flag, and we can also check this flag in the next stage, like a grab 2. Also, and it's very simple. They have one tool, Python tool can state or check the NX compared flag in the EFI binary. Okay. Okay, then extend to the topic. So now we know we need support the NoSQL, but in many cases because we are bootloader, so we need to load the code to one memory region before it jump to the code in the region. So we still need to allocate a memory which is can be write before we say it's a read only. So we need one protocol to let us to set those attributes in memory region. So now originally this protocol is defined by the UEFI spec, and actually it's almost more than 2 years. But so the first platform has implemented this protocol. It's not really long time. You know, Bhutan protocol is a Microsoft's a new piano platform. It's one of virtual machine firmware just for. They say they deliver. They use it on the cloud. I'm not sure it's a real, but yeah, they claim it support this. Yes, of course, it supports protocol. Then we can use it for development. And now the more important is since 2025, the 02 this version, the EKU start to also support this protocol. So why is it important? Because all the OEM, ODM manufacturers are based on the EKU source code to develop their firmware. So which means more and more machines will support this protocol. Yeah, then we can run those NX Shim on those machines. Then after that, we start to find some bug, and so I filed a bug, and now after debugging with Michael Zhang and Gary Lin, who are our Grab2 experts, so now Grab2 have one old Grab2 master report one page for the 4K alignment, and I am also send a page to the Shim upstream for the checking the NX flag. If the Grab2 does not set the NX flag, we should not call the EFI memory attribute protocol. because does not make sense. So, but the page is still reviewing, and more page in Shim related to NoSQL, and actually the 15.a we already enabled the NoSQL flag by default, and when building we can use one build option to disable it, but in SUSE Shim we already enabled. That's why we found a bug on with the OVNF EDK to OVNF. And interesting things is since 16.0 it start to support for using the DSE memory attribute update. Because in the UEFI firmware, it have some different stage, like when putting is a SEC stage, then next is a PEI stage, then next is a PXE stage. After DXE stage, it hand over to the bootloader. So it's a DSE stage is have some service. It should not be used by the bootloader, but interesting, the code is still there. So some if the firmware does not support this new protocol, is a official support protocol, then we can try to find the DXE protocol and use it in bootloader to set the memory, the attribute of the memory regions. After we write the code, then we can set it to the read-only and the executable. And there have one flag can set the if our MOK path is if we support our environment support the NX, but now I'm not sure anyone to use it. Maybe in the future someone will use it. Okay, then next topic is a certificate wrapper. It's a totally different topic. It's as we know the process. Let me back to the process. Yeah. Every time the code, the binary be changed, all the key for signing the Shim binary be changed, we need to send it to the Shim review project for review and the sign. Unfortunately, the sign stage normally spends many time. Sometimes to 1 month to 3 months even. So it's we try to contribute the Shim review. Sorry, I forgot one thing. Dennis, I forgot. Not me. Dennis Zheng is our team member who is in Taipei also. He cannot join here, so I put him in his name here, and he helped Dennis help to contribute to the Shim review project, because on Shim review project have many different distros. Shim will send it to the Shim review, so the community is close review each other and try to earn the more credit. Yeah. So but we are trying to continue to contribute it, but currently it does not help to increase the speed of the sign. We are still finding the way. So back to the feature of the certificate wrapper. So if we want to change something like a DB, vendor DB or SBAT string in the Shim binary, which means we need send to the Shim review again. So that's why we have now have a list of new function. We don't need to change the Shim binary. We just have build another UEFI PE binary, which is include a DB and also new SBAT string in the binary. Then Shim just load the binary, but the binary must be signed by SUSE key. Then Shim can verify the binary by SUSE key. If success, then then the new DB and the all SBAT will be used, apply. So there's some detail I think we can skip. Then the first one is DB. The certificate wrapper can be used to enroll a key to as the MOK. We say DB, but actually it's not really enrolled to the UEFI DB report. It will be enrolled to MOK list. So it's some detail for the page in the Shim, and also the DB will be put in the .db sections in the binary, and we can simply use the object dump to dump the DB block and use the signature list to certificate to dump those keys. The format is follow the EFI specs. The EFI signature list is one container of the one list, of course, a container of the keys. And another feature is for the certificate wrapper, we can put a new SBAT in the EFI binary. Then Shim can verify and load it. So it will be put to the .SBAT sessions. And why have this slide? Because now sometimes we will confuse what keys will in the MOK be. Okay, thank you. The MOK be exposed from the bootloader to the kernel. So here have 3 different sources. One is the original MOK, and another one is the key embedded in the Shim, and the third is we just say is a certificate wrappers keys. So for the MOK certificate wrapper and MOK, quite simple. Shim just he will check if there have one Shim underline certificate EFI, the name is fixed, is hard coded in the Shim source code. Then it will load and verify the EFI binary. If it's past the verification, then it will load. Shim will load the key in the DB session. Then it will also load the original MOK list. Then combined with the vendor certificate in Shim will generate one runtime. The MOK list runtime variable. It's a volatile variable which will disappear after reboot. So, but the kernel will load this MOK list RT variable as the source of the all MOK. Yeah. So this feature also show that the keys in Shim certificate .EFI will not be write to the MOK real MOK list. Because so which means if you remove this EFI file, those key will also be removed. And SBAT is different. It's the same thing is Shim will load and verify the revocations EFI, and they have one session. The name is SBAT A. A means automatic, and SBAT L means latest. The different policy, the different stream for the different policy. So then it will check the SBAT policy, current policy, maybe the latest, automatic, or reset. Reset means just reset. Yeah. So then it will check the policy, then compare the string in the session to the current SBAT level, then update it. If those two is newer than the timestamp is newer than the SBAT label, it will be the SBAT will be updated. Okay, another feature is I think this is more easy. Is because we just say the SBAT label, those SBAT string be building in the Shim binary, and so when building we can choose the different dates. But originally we use one header file to to comment those information. Sorry for this picture isn't the color is not good. So it's just very simple to show the now we have a one text file to put those SPAT session string and also have some comment in this text file. Then we have one tool to transfer this text file to a header for the SPAT string. The next function is configured for the second stage. Originally the default second stage bootloader is a grab true. Yeah, thank you. And so now, but in some cases, we some destroy, which means openSUSE, they rename the UKI universal kernel image to grab, then to treat the booting of the Shim. But now we have one CSV file. The name is options.csv, and they use the Unicode little endian format. So we just need to put one entry. Currently, is only allow one entry to then the Shim will load this file and to find the next stage. Of course, the next stage must be signed and passed verify. Signing EKU support, we contribute this function to the Shim, but actually we already support it a couple of years before because we want to pass the NIAP PPOS certification. So we Gary Lin, who is in the SLA team now, he developed the original page. Then Dennis Zheng development another one, and we push it to the option success. So now Shim official support this function. So if you use the openSSL tool to show our CA, you will see the extend key usage is a cosign. The latest topic is a one special thing. LVFS is a firmware update daemon. This organization they launch one spec is a host security ID, which means they define some level of security. Of course, almost for the firmware to identify the security status like insecure, critical state, risky, and these are some point here, like if you want to fulfill the critical state, you must has the SMM lockdown and the UEFI private key check and the UEFI secure boot enabled like this. Then there's a stage, there's a label is this one. But I'm not want to promote this aspect. Point is Shim now export one variable. The name is HSI status. It export some information for because the memory region of the Shim be allocated by the loader in the firmware. So Shim will check the loader region, the attribute of a loader memory region to know if the firmware is really supported non-execute, is not execute. So like the heap should not be execute. So if it can execute, then this bit will be raised. Then stake, if stake can execute, is executable, then the bit will be raised. It's not good. And then many different bits for almost for the no execute. I'm not sure this information is useful for other place, not just HSI. Maybe is good for our ES certification, because our partner will send their machine and firmware for our ES certification. So maybe we can know those firmware is really support no SQ or they are not really SQ. Okay, then it's a reference. Thank you. Then I finish. Thank you. I'm not sure. Any question? No. Is time up? Okay, then thank you. If you had any question, just tell me. I'm here. Yes, thank you.